Go. Hello, good evening. Once more, this is Cloud Training for Enthusiasts. I'm your pilot, Patrick Osatoame Agbogun. And today is going to be another interesting time because we're going to be talking about something that is most powerful and something you cannot avoid as a DevOps engineer, even as a cloud engineer. And we're talking about infrastructure as a code. Infrastructure as a code. It's a simple language, infrastructure as a code is IAC, which means you deploying a public cloud infrastructure using a third-party application that offer it as a code. So let me put it again. Deploying an infrastructure in a public cloud using a third-party application. So that third-party application is offering code, that is sharing code on the internet that you can use to deploy infrastructure in another public cloud. You understand me? So AWS have their own CLI. It's called AWS CLI. Azure has their own CLI. You understand? Google Cloud have their own CLI. You understand? And AWS also have their own platform as a they have their own platform as a service called CloudFormation. We also have, there are so many, you understand, so that you can through there deploy your, if you are using CloudFormation, all you just need to do is to design your stack. It's also a code. Just use your code to design your infrastructure. I want to talk about it in our other classes. So we also have other third party that is from AWS. While Azure has their own, Oracle has their own. You understand me? Google Cloud has their own. But there are other third party companies. Their own is not, they are not really AWS or Azure, but they are just third party company that just provide code. And the code they are providing for us is to use that, we can use that code to deploy infrastructure in either of these public cloud, either Oracle, Azure, AWS, IBM. You understand? As far as they are supporting it as a provider. So those companies that offer such code, they are offering infrastructure as a code. Yeah, the infrastructure, they are providing infrastructure as a code service. Why we using it? We are using code to design, to support, to automate, to create infrastructure in a public cloud. So it's as simple as that. So example of infrastructure as a code company that provides infrastructure as a code company, we have the Ansible. I think Ansible is owned by Oracle. Then we have Terraform. We have Puppet. There are so many, but the most popular one is the Terraform, Ansible, and Puppet. You understand? But for us, we are going to be talking about Terraform. Terraform and Ansible, both of them, they have just like two public cloud trying to look for who is going to be the best. Both of them are very, very interesting. Terraform is very interesting. It's like building a block, building a house. You know what I mean? Like you put a block here, you set up the block, you set up a block, you set up a block. The same thing with Ansible, just that Ansible, your indentation must be the same, must be online, it must be aligned. But for Terraform, the indentation does not really matter. Are you getting me? And if you
just like Java and Python.
You understand me? It doesn't really matter. You must not look for, you must not be in straight line. As far as you are right, you know what you are writing. And if you want to deploy, remember, if you want to deploy, you deploy your network first. After your networking, you will not deploy your instance. But when you are using Terraform, if you like, put your instance first, put your provider last, put your subnet anywhere. Terraform does not really care. As far each block is complete and each block can run successfully, you understand me? It deploy your infrastructure for you. So it's very, very interesting. Terraform is very, very interesting. So that is what we are talking about now. So welcome again. I want to be. Let's start from the first. So I think I have some presentation here. We're going to run through this presentation to prepare us. before we go into the real thing. So Terraform infrastructure as a code. So what is Terraform? Terraform is an infrastructure as a code tool that allow you to build, change, version infrastructure safely and efficiently. This includes low-level components such as compute instance, storage, and networking, as well as high-level components such as DNS, DNS entries, software as a service features, etc. Terraform can manage both existing service provider and custom in-house solution. You understand me? So, custom in-house solution, so you can use it. There are some companies, they like to keep their stuff to themselves. You understand? So you can use it for both public provider. You can also use it for other infrastructure like your own normal in-house on-prem infrastructure. You understand? So it's not like it's a must, everything must, but most, like for me, I mostly use it for public provider, for service provider. Okay, what about Terraform language? It's just like every other program, just that this one is not like a programming language like Python. You know Python, you use Python to design your APIs, use it to, you understand me, to do your back end and your front end, full stack. But Terraform is not really like something you use to design a full stack. It's a tool. You understand me? Just like every other, like Linux kind of tool. You understand me? Just like Linux, it's a tool. So it has its own programming language. The programming language is called HCL, which is HashiCorp command line. So HashiCorp is the owner. They are the designer. They are the patent right owner of Terraform. Are you getting me? They are the patent owner. So they have their own language called HashiCorp. So this language is very close to human language. It's like a script. It's very simple. It's very, if you can understand Python, you can understand it. They are similar. Yeah. You understand me? Just that there's no like all those function, Google, Tibo. So they have their own way. It's very interesting. You will enjoy it. Oh. Which other thing do I need to talk about? Terraform. The extension is called .tf. That's the extension of Terraform. So, and the interest.
Extension.
And that's the extension.
File.
Yeah, the file extension, .tf. Yes, .tf. So they also have .hcl. You understand me? They also have .hcl. Then the other, but their major file is written in .tf. And you so TF means Terraform. You understand? So the main purpose of Terraform language is declaring resources which represent infrastructure objects. So all other language features exist only to make a definition of resources more flexible and convenient. What does that mean? Is that when you are talking about Terraform, Terraform mostly is used to send instruction out. So it's a declarative language. You understand? Create instance, launch instance. Are you getting me? Update instance is declarative. So although you can also use it to import existing instance, maybe you have an infrastructure, you can use it to import existing infrastructure into your Terraform playbook so that you know how the infrastructure will look like. You understand me? So that is the another interesting thing about Terraform. Immediately you create a playbook. A playbook is that block by block infrastructure that you already set. You understand me? It's a playbook. It's called a playbook. You understand? So when you apply that playbook once to that infrastructure, it will look. It has a history that it collects all the logs of the infrastructure that you have already deployed. If you reapply it again, the infrastructure you have already deployed, if it's the same infrastructure you are deploying again in the same region and in the same place, it will not deploy. It will tell you that this infrastructure is already exists. That's interesting. So it's difficult for you to duplicate a resources using Terraform because most times the advantage of it is that when you want to replicate a certain infrastructure in different region or in different cloud provider, you are very sure that the infrastructure you deploy in zone A is the same the infrastructure you deploy in zone B. Because immediately you click apply, it will go and create the exact infrastructure that you have before. So you see, it's very easy for us to use. For example, if I have a solution, infrastructural solution that I've created in a South Africa availability zone, South Africa region, maybe as availability zone 1B, in that full region. You understand? Now, maybe you will now have another infrastructure. Maybe our company now said, oh no, we have gotten another subscription with the same AWS, but with another infrastructure. Come and replicate the exact infrastructure that you were having before. But you see, it's difficult unless you have a proper documentation. It's difficult for you to replicate exact.
The same.
You understand me? Talking about VPC tunnel, talking about DNS name, talking about your load balancer name. You understand me? Your IP address, everything. For you to have that exact infrastructure in another region is, if you are going to pass through, I'm talking about if you are using normal console, you know, it will be difficult for you. But because you are using a Terraform, and the infrastructure is what you have in Terraform, so it will be just easy. What you just need to do is to change the programmable access key and ID, and change the region to South Africa. Then you just apply. Immediately apply successful. If you can work in region A, it will work in region B. So you are very, very clear that what you deploy in A is what you deploy in B. So in case you want to do cleanup, you know how difficult, how stressful it is for you to go and be deleting instance. You delete all the instances first. You now go to the load balancer. You delete the load balancer. You now go to S security group. You delete the security group. You now go to the ACL. You now go to EIP. You delete. You now go to private subnet. You delete public subnet. You know, before you delete, imagine if you are deleting for more than 1,000 instances or 500 instances. You use 1 year to do it. So, but with Terraform, even you say destroy, Terraform destroy every infrastructure that playbook deployed will be erased from your infrastructure. You see, it's very, very clean. It makes your workplace clean. Are you getting me? You understand? It makes your workplace clean. Then that does not mean it does not have life cycle. You can also decide to say, this instance should not be destroyed like this. It must, you understand me? You can decide to do some life cycle so that somebody cannot wake up one morning and say Terraform destroy your infrastructure. There's a way you can also protect your infrastructure so that even with Terraform destroy,
password.
With password, and understand. So there are many ways you can secure your Terraform file playbook so that somebody cannot just use it anyhow. So there are many things that are acceptable, that are not acceptable. I want to be talking about it. Fine, I also know that this is not 100% Terraform class, but I'm going to do my best to go a bit detailed about Terraform because we need it. So Terraform is an open source, which means you can download the application on your system, configure it, and use it free of charge. You understand me? They also have another one, which is called Terraform Cloud. That one you pay for subscription. They will help you to secure your files. You see, as I mentioned now, if you notice from where I've analyzed Terraform, if you are using a Terraform in a certain company, it means that it's a very, very critical document. You understand? It's a very critical document. Any document that can destroy your infrastructure. When you are talking about availability as a cloud characteristics, Terraform is not something you play with. That playbook is not something you play with. So Terraform Cloud helps you to protect so many things. They give you, so you only pay for the commit, you only pay, you understand me? They secure it for you. They secure your files, secure everything for you. Although you can also secure it on your own, but they provide more security to your infrastructure. You understand? So Terraform configures and complete documents in a language that tells Terraform how to manage a given. The Terraform language is declarative. Well, that's what I was explaining just now. It's declarative. That you use it to give command. You declare it. You understand me? Describing an intended goal rather than step to reach that goal. So before you even deploy your infrastructure, Terraform will first of all analyze everything you want to do. It will tell you the number of resources you want to deploy, where you're going to deploy it. It will give you the breakdown first. It's called planning. Then until you say apply, it will not say okay. Even when you say apply, if you didn't make an auto approve, it will also tell you how many resources you want to apply because he's careful. You understand me? He's careful. He's always telling you. He's always telling you what you want to do, what he can do for you. He will tell you everything before he do it. Before he does it. So the Terraform is declarative, describing and intending rather than step by step on how to reach the goal. On the ordering of blocks and the files they are organized into the general not significant. What does that mean? You can declare your VPC in the first line, and come to the last line and declare your subnet. We all know that if you are declaring VPC, subnet should go close to it, Abi. Internet gateway should go close to it, but they don't care. You can decide to, but as far they are all in block, each block is complete. Each block is independent. So for the case that it did not see any block, it will use the default block in your resources
to create it.
But there are some times that you have to just declare it. So that is it. It's very simple. So that is it. In ordering blocks and files is significant. Terraform only consider implicit and explicit relationship between resources when determining an order. So it's talking about, so what I mean by implicit and explicit resources is that in case you want to deploy VPC and you already declare a subnet, if the subnet is declaring the VPC ID, are you getting me? So the Terraform will now say, oh, okay, this subnet is attached to this VPC. So automatically it will look for the implicit relationship. Are you getting me? And so, so if maybe you do three subnets, it will ask you, when you're even declaring the subnet, it will ask you which VPC are you going to deploy it on. So if you declare any VPC, Terraform by himself will be the one to say, okay, subnet A is for VPC A, subnet B is VPC B. How they do it, that it's not your concern. Are you getting me? He's the one that will manage those things for you. So these are the things. So these are the pattern. It has a structure, it has a syntax, it has a block. A structure means the way you arrange it. You have parentheses. We are going to be seeing it. And each structure, it can either start with a module or a block or a provider. Are you getting me? So it depends. So each module has a syntax. A syntax, normal language now, just the way every other language is. Has a way you must follow that pattern. Even English language have syntax, so you should understand it's a programming language. So it is arranged in blocks, where each blocks are different from each other. But we can have a sub-block. A block can have a sub-block, but each block must start with a parenthesis. It must also end with the parenthesis. Are you getting me? So when there's one parenthesis mixing in between, it will assume that it's a sub-block of another block. And if the Terraform now scan through the other block, they don't have any relationship, we will declare an error. Okay. Understand me? So he has an argument, he has an expression, parenthesis. Like argument, just like the way argument now, like using logic or, and they also have expression. It has an equal to, you understand me? VPC is equals to this one is equals to this. It has an expression, let this is equals to this, create this, you can also use the environment also accept commenting, you can comment it. Any block you comment out, the Terraform will see it as it's not part. It will not see it as anything. We see it as a statement. You understand me? So blocks are containers for other content and usually represent the configuration of some kind of object like resources. Block have a block type, can have a 0 or more label, and have a body that contains any number of arguments and nested blocks. That's what I mean by nested blocks. So you can also have nested block where one block has another block inside. Most Terraform features are controlled by top level blocks in a configuration. That's what I'm also explaining. A top level block. Maybe you want to create an instance. Are you getting me? You want, before that instance finish creating, you also want to load file into that instance, load an application into that instance. Are you getting me? You can decide to install your Apache on that instance. Configure, tell where the Apache is going to go to push some files from one place to the other. You can do it with Terraform. You understand? So that is it. Arguments assign a value to a name like that. Expression represents value, either literal or referencing the combined order that appears on the value of argument or within other expression. You can pull one and call B. Then we also have what we call parentheses. I told you about parentheses. This first one means blocks. This one means for comment. Why this one means this one, you know, this hashtag is for comments. If you want to comment, then this column and semicolon, this quotation mark 2, either you use 2 or use 1.
For comment 2.
You can also use it for comment. You can also use it for expression. This quotation, you can use it for expression. You understand me? Then example, which is equal to. You can also use this quotation for comment too. So this is how the block is. You see, it starts with quotation, it starts with parentheses. This is a block, this is a block. You see the quotation coming in. See the quotation coming in. Then you see the parentheses. This is how this is a typical Terraform stuff. You say the name, the block. This one is dependent on this. This one is dependent on this. You can say resource, VPC, then VPC ID. Resource, VPC, VPC ID. So these two are one. Just that this is like VPC, this is the ID. You understand me? So the block is identified is equals to, this is the body for identifier. Identifier, like you can say VPC expression, which is 2.1.2.2.2. You understand me? Then you can put the comments in between. The comment can come anywhere to explain. This is why we always use comments on VPC, on HCL in a playbook, so that those people that were not there or someone that did not know what you did, but by reading through your comments, can understand what each block represents. So for example, now if you want to declare a resources for AWS VPC, you see resources, the resources you are deploying is called AWS VPC. And the name of the AWS VPC is called main. You understand me? This is a cider block, means var. Var means variable. If I also tell you the meaning of variable, AWS also use variable very well. Maybe you have declared a variable somewhere. You want to pull that variable. You want to reference the variable. You use var. You understand me? So I will tell you, so that you'll not be repeating one thing and one thing and one thing. So you can just use the variable and declare it. So that is it. So these are the features. So sorry, as I mentioned, we're going to spend time here because this is the main thing. This is, if you can understand this, by the time we are now going back, I'll be referring to this. You describe your infrastructure using Terraform high-level language, high-level configuration language, which is called HCL, in human readable declarative configuration files. This allows you to create a blueprint that you can version, share, or reuse. You understand me? So you can have version 1, 2, and 3. You can share, you can also reuse it. So execution plan is called a playbook. So that plan that you already designed, those book, that file that you create everything on, are you getting me? That has .tf. Each of that file is called a playbook. The total of every file is also a playbook. You understand? The interesting thing about Terraform is that you can have 5 documents in one Terraform folder. Are you getting me? You can declare one of the documents, you can declare it for VPC. Second document, you can declare it for the resources. The third document, you can declare it for your license. You understand me? The fourth document, you can declare it for your variables. Sorry, all of them has .tf. So whenever you say you want to deploy that infrastructure that is in that 5 documents, Terraform will screen through all these files and deploy it as if they were in one document. Are you getting me? So it's better you do it. That's the best practice, so that your document, your file, your distance will not be so long. So maybe you want to tell somebody to look at your VPC file. Maybe you want to query, as maybe there's an issue you want to debug. You understand me? You know where to go and just look at where the issue is. Instead of looking at a whole file that have 120 lines, it will not tell you line 45 has issue. You will not be scrolling looking for line 45. So it's better if you can just keep each block, each playbook to have a certain function. What I'm telling you now is from experience. It's from experience.
So, can I ask a question?
Go ahead.
Now, if we have many files,
yes,
with the .tf, and do we need to import anything that will link those files together?
No, automatically, as far as they are in the same folder and you are initiating your Terraform there, you will Terraform init in that folder, just like the way Git is. You know, when you create a folder directory, immediately you initiate Git in that directory. Git sees that whole directory has something that is in control of. So whenever you want to say Git commit or Git push, it will push the whole folder because it feels that that folder is under his control. So anything you put in that folder, any file you put in that folder, Git will recognize it. It will tell you that this file has not been committed yet. That's for Git. Same thing with Terraform. As far as that folder, you have initiate Terraform init on that folder. Terraform take possession of that full folder.
Okay.
So that is it. So just that you cannot declare the same VPC with the same characteristics. You understand me? In that folder, for example, one VPC cannot, two VPC cannot have identical CIDR block or identical name. It will tell you that this name and this CIDR block already exist. You push an error. So they must be unique. So each CIDR block must define a unique resources or a unique variables. You understand? Right. And so that's so that it can see it differently. You will enjoy it when you are doing Kubernetes, when we are doing Docker. Don't worry, we're going to start. I can't wait to even start the practical, but let's just go understand this. Okay, resource graph. Terraform builds a resource graph and create a module node dependent resources in parallel. This allows Terraform to build resources as efficiently as possible and gives you a greater insight into your infrastructure. So if you go to your history, are you getting me? You see everything that Terraform have deployed. Then if you go to as you are even deploying, you will see step by step, whatsoever thing is deploying, it will tell you this one is creating now, this one has finished creating, this one did not create. You understand me? This one created successfully. You understand? It depends on how you design your workplace. You can design it that if any resources do not create, you should stop. You can also design it that any resources that do not create, skip it. Are you getting me? But tell me later after you finish deploying. So that is it. So you can change automation. You can that's the graph. Then change automation. Terraform can apply complex change sets to your infrastructure with minimal human interaction. When you update configuration files, Terraform determines what changes and create incremental execution plan to that respect. Now, this is another thing. Depends on how you design your Terraform file or in playbook. Sometimes you are not careful. If you alter your resources, maybe your resources you are trying to create EC2. Are you getting me? Maybe your instances is like Ubuntu. You use Ubuntu as your AMI when you are declaring your instances, and you now went and changed the Ubuntu, and now from your playbook you now say instead of Ubuntu you want to put Amazon AMI. If you are not careful, Terraform will destroy that first Ubuntu and will create another one to replace it. So you see why you have to be very careful. As you can also define the kind of update. You can also define your update file so that it will not destroy the first one. Are you getting me? You understand? Okay. It will create another one, wait before it destroys. So it depends on how you define, how you create. So Terraform is a very interesting thing. Why I love Terraform is that you may not need to learn all public cloud. Remember when you were telling me that time that you are doing another public cloud, you may not need to learn all public cloud. If you can understand one public cloud very well, just know the basics of other public cloud. But with your Terraform, you already know what you want to do. You understand me? By the time you design your architecture, your blueprint, you bring it, you now use your Terraform to deploy it in other resources. Because in Terraform sites, they will tell you the equivalent. You understand me? They name this one, calls it. So you just copy the file, put it in your playbook, do your normal adjustment, personalize it. Are you getting me? And apply. So that's why for me, I can work in any public cloud, any cloud that Terraform supports. So that is it.
Yeah.
So how to use Terraform? You need an internet. That normally, you know, everything cloud is internet now. Without internet, there's no cloud. So you need either a Windows, Mac, or Linux PC. Understand me? So if you have a Windows, if you have a Windows, you're still going to use your CLI because it's a CLI. It's not. I think there's a Terraform that uses GUI. Yes, I have seen that too. But the one we are going to be talking about is more of CLI. You understand me?
Yeah.
We're going to be talking more about CLI. Then you have CLI. Then we have Linux, Mac, or Windows. So then you need a text editor. A text editor. For you can either use you've heard of Python, you have Anaconda.
Anaconda.
Yes, Anaconda is a
Python.
No, Anaconda is like it's also a IDE, integrated. Oh God, IDE, normal environment now. Normal environment for
the one
coding.
that we use the Jupyter Notebook.
Yeah, we have Jupyter Notebook, we have Anaconda, we have VSC Code. You understand me? We have VSC Code, we have Anaconda, there's so many. Because when I was learning,
Spider.
We have Spider. When I was learning coding then, you know, different programmers, different developer, they have their own environment that they are used to. You understand me? Integrated development environment, IDE. So and you can also use Notepad. Funny enough, most people like to use Notepad. You understand me? Most people like to, normal Notepad now. You can use it as your IDE. But for me, I like using VSC Code because with VSC Code, Visual Studio Code, with VSC Code, you can install so many plugins on your system. So that with that plugins, it can help you to, make your code very interesting. Then VSC Code is it has so many plugins. With that plugins, you can design In fact, it can even help you to ident. You can also help you to look for fault. Before you even run the code, it will tell you this part has issue. Depends on the plugins you are using. So we are going to install a VLC code. We are going to install Terraform application package. Then you are any supported public cloud, like for we are using AWS. You're going to install AWS CLI on your system, because it's through that CLI that the Terraform will be communicating with. You understand me? Then from there, the Terraform will be communicating with the CLI of AWS or your public cloud. Then that your public cloud will be communicating to your infrastructure. You understand?
Yeah.
So that is it. You're going to have a public cloud. You must have a private account programmable access. You know, when you were creating an IAM that time, can you remember? It will tell you, is this account going to have a console or a programmable access? You know, we always say allow programmable access. So it's through that true access, the access code and identification and access key is what you are going to use to configure your playbook. These are the tools you need to use a Terraform. So we are going to, when we start, we are going to do those things. Then the resources. So resources are the most important element in Terraform language. Each resources block describe one or more infrastructure objective, such as virtual network, compute instance, or high-level components, such as DNS record. Resource block document the syntax for declaring resources. So each resources has their own block. They have their own pattern. You can modify it, but one thing about Terraform, they already design it already. They already know what, you understand me? So what you just need to do is to go and copy. For example, if I'm deploying a VPC, and so I will just go to Terraform site, copy that block for that VPC, and modify it. You understand me? You copy, you just go copy and modify. So resource behavior explains in more details how Terraform handles resources declaration when applying for a configuration. When you press Terraform apply, Terraform will tell you everything about the resources. It will explain to you the behavior. Metadata section, so it will tell you, for example, you want to say count. Count means if you want, maybe you want to create 20 resources. It depends on the block. Some block does not accept count. You understand me? Some block accept count. You can say count. If you say count 5, meaning you are deploying same resources in 5 format, in 5. Sometimes you don't need to use count. You need to use some iteration. Normal either if you know, normal iteration are I in I, iteration for the for loop, for loop and while loop. You're going to declare that while loop or for loop in a way so that it can give you that iteration. So then for the provisioners document configuration post creation action of the resources using a provisioner and a connection block. Since provisioners are non-declarative and potentially unpredictable, we recommend that you treat them as last resort. So you can decide to attach a provisioner to any resources you want to do. For example, as I mentioned just now, I know I'm always talking about EC2. You can decide to say, okay, after the EC2 have been provided, the resource EC2 resources has been created, help me to provision it. So you use a provisioner to load files inside. So there are different types of provisioners. Provisioners can be used to model specific action on a local machine or on a remote machine in order to prepare servers and other infrastructure objects for service. You understand me? You can use it to provision a resources. You can use the provision a database or whatever resources. But mostly provisioners are mostly used for resources. You understand me? For a very solid resources. So these are the parts of Terraform. One, we have this Terraform file, which is the TF file. We have the Terraform state file. That one tells you everything about what is going on in the Terraform. We have the Terraform state backup. It backs up the state. So that in case anything goes wrong, you can also revoke it. You understand me? And maintain. So if you delete your state file, Terraform will not know what you have deployed with that playbook. So automatically we try to deploy that infrastructure again. But you first of all have to initiate. Then we have Terraform lock ACL. This Terraform lock ACL is like Git ignore. It helps you to lock some vital parts. So that's why when you are using Terraform, and you cannot just go there and install Git and initiate Git on the Terraform directory, and you say Terraform, you cannot say Git push. It will not push some files because of this lock ACL. So it will lock the every .tf files. You understand me? So .terraform .terraform file will help you, for example, if you are deploying AWS. When you say git Terraform init, the Terraform will go to AWS and look for all the necessary support dependency that those resources you want to deploy in AWS need.
Yeah.
So you go to AWS and look for all the things required for it. For example, you want to launch a VPC and a EC2 instance. You go to AWS and look for all the things that it needs, and you get me, and put it in this .terraform file. But if you later say you want to deploy Kubernetes, it will tell you that you have to create and initiate again. When you initiate again, it will look at the file, you go to the internet and pull those things needed in your Terraform stuff before you initiate. So Terraform, when you talk about variables, maybe I mentioned that you can create 5 instances. You can create 5 Terraform file with specific resources. But you can call file A in file B. For example, file A, VPC ID is oshomole.abuja ID. Then if you want to use that Oshomole, instead of it to be declaring the same, creating on that VPC again, you will just say var. Are you getting me? You put a $sign, you call that file, the name of that file. So the Terraform file will see that syntax and connect to the first file. Are you getting me? And create. So that aspect of connecting to a file that has already been existing before is called variables declaration. So I'm going to be talking about that. So we have 2 types of Terraform files. We have 2 types of Terraform. We have the open source, which is the one we are popularly used. We have the cloud, which I explained before. Then some simple usage is used for simple infrastructure as a service, like the one we are doing now. You can also use it to do platform as a service. For example, you can use it to create FortiGate. FortiGate is a platform as a service. You can also use it to create what I think it supports WordPress. Supports so many applications. You can even look at any infrastructure that are already existing. You can go and copy the source code and put it in your Terraform and launch it to create automatically. So it's software as a service. You can also use it for software as a service infrastructure. We always advise you to make a playbook simple, though you can write all your declaration and configuration in one file. We always recommend you put different aspects of the infrastructure in a different file for easy debugging and understanding within your team. Put your credentials safe. You must also secure your repository and has a data lock for authorization, because if anybody should have access to your access code,
you can delete it.
You can delete your infrastructure. Because it's not like using the second factor authentication. This one not get second factor authentication. Immediately you just go to Terraform, you will just screen AWS, analyze if that file is there. Immediately you just see the access code and access key. We all grant the Terraform access. You will be deploying. It can destroy your infrastructure. That's why whenever you want to do, you have to put that file in your git ignore folder. Okay. So your security must be uptight. So you can create VPC with a default, you can customize, you can semi-customize. These are for your network. If you want to create a network, you have to create your VPC. These are the things you must add. You must declare your VPC, your subnet, your route table, your internet gateway. If it's a public subnet, if it's a public, no whether public or not public, you need internet gateway for a VPC. You understand me? Because with the internet gateway, that's where your resources will be able to update. Whether you're using NAT-gate or you're not using NAT-gate, you must declare your ingress or your egress in your security group. Then setting up instance, use your default network setting, customize network, preload user data, load balancer, auto scaling group, and role-based access control. Rollback, like I'm talking about IAM, as a role-based and all that stuff. I think for now, we have talked about every other thing. So this one is setting up, create a variable, provider, region, VICD, private stops. So this one is already practical. It's already lab. I think with this, we have talked about Terraform theoretically. So any question? So this is Terraform in view, in a simple expression. So any question?
No.
So you understand it clearly?
Yeah.
So what I'm going to do, I'm going to cut this. Okay. Or since there's no question, I believe we are ready for the main thing. Okay?
Yeah.
Okay. So hold on.